then your skeleton's not right. If your skeleton's not right, then your coefficients from your balancing is not right. If your coefficients aren't right, then your mole ratio is not right. And if your mole ratio is not right, all of your stoichiometry is wrong. So it does build from here, making these things right. Now, so for this, and don't worry, we're not doing algebra in here. I'm just using X's and Y's to show you this works with just about everything. We're going to figure out how many of X and how many of Y are present for each of these. So this first one, I'm going to freeze this so I can move my cursor. This is the easiest one. There's no tricks to it. How many X's are represented with subscript 2? And just like the subscripts that we use with elements. How many Y's are represented in the first one? 3. And that's about as straightforward as it gets. Now this one, what happens when you have a number outside of parentheses in your math class? What's the word that you have to do? You distribute, which means you multiply. It's the same thing, that it's distributing. Now how many X's do you have? 4, because 2 times 2 is 4. I'm not trying to insult anybody's intelligence. I'm just making sure that everybody's on the same page. And how many Y's do you have now? 6. You don't add, you multiply. How many X's do you have? On the middle one, it was 2 times 2, which is a total of 4. It's just like you do in Algebra 1. I don't even know if this is considered Algebra 1. And then Y would be 2 times 3, which is 6. Now we get a little bit more complicated. Okay, so we have the number outside the parentheses, like we do with polyatomics, but I also have put a coefficient. It's a new word, a coefficient in the front. Both of those numbers, the big number in the front and the subscript, they both multiply the things that are inside. So how many X's do you have now? 12. So 2 times 2 times 3, 4 times 3 is 12. Well, that's literally what we are doing today. And we're going to go back over reaction type 2. If you missed the quiz from yesterday, I believe it's still open if you were absent. I will double check that once you guys are starting the assignment. How many Y's do you have? 18. You have 2 times 3, which is 6, times 3, which is 18. Okay, I don't think there's going to be, but are there any questions how we just did that at all? Like, at all? This one, all right, so this 3 and this 2 are both multipliers. Okay, in chemistry, when we write out our equation and we balance it with a coefficient in the front, it multiplies everything behind it. When you have parentheses, the number outside multiplies, I can speak well, everything that's inside parentheses. So my X, which originally had 2, was times 2, which was 4, then times 3, which was 12. Okay, and then the Y, originally, it's the same thing. Okay, as we go, you can, but a number outside of parentheses only affects something that is inside parentheses. It doesn't affect anything that's outside of parentheses. And I'm going to show you one that's like that. That's about as tricky as it can get. Because when we get into stoichiometry and we do molar mass, these numbers mean things. Now, you're pulling masses off the periodic table, and I don't make you memorize that thing. But you need to know what to multiply the mass up there by to calculate how many grams 1 mole weighs. Like, I know 1 mole of water weighs 18.0 grams. I know it does, because you have 2 hydrogens, each one is 1. 2 times 1 is 2. And then you have 1 oxygen. Each oxygen has a mass of 16. 1 times 16 is 16, plus 2 is 18. So 1 mole of water, if I weighed it on a scale, would weigh exactly 18.0 grams. That part's not the hard part. The hard part is getting all the other little bits together to be able to do the math in chemistry. But that's way down the road. Right now, we are literally counting atoms. Is there anybody that wanted the paper version that did not come up? No, because it's online. Subscripts, I don't have the paper in front of me. The subscripts tell you how much of that specific element you have. Whatever that element is, the number that's right after it is how many it has. If it's outside of parentheses, which was the last one that we did with the opener, it only multiplies the things that are inside parentheses. Doesn't multiply. Here, let me show you an example. So like if I did, I really shouldn't have picked green. Let's see, I have a 4. That's really, I need a 3. So this 2 only affects the oxygen and the hydrogen. It does not affect the calcium, but this 4 affects the calcium and the oxygen and the hydrogen. That's the difference between a coefficient, which I think is the next one. Yep. Coefficient is the number that's in front of the compound. We use those to balance. I haven't taught you how to balance yet. Like I said, we will start that Wednesday. I have it already pre-recorded and put into Canvas for you guys Thursday. And then I know that there's going to be questions because the harder balancing things are Thursday's lesson. Combustions and skeletons with polyatomics are not the same on both sides. Or you have to break them up. Now the last thing that's on here is sometimes you see little letters after the compound, and that is the state of matter. It means nothing to do with math. A little S is a solid. This is a little L. I mean, not an I. It's a little L is a liquid. A little G is gaseous. And the AQ is aqueous, which means it's in a liquid state. Aqueous does not mean water. It might look like water, but don't drink it. It could be hydrochloric acid. Hydrochloric acid looks exactly like water. It doesn't feel like water when you get it on your skin. But this AQ, this is very, very commonly, this is after an acid. I wonder why that animated that way. That's odd. It doesn't look that way on my screen. I don't know. Google Slides does some weird stuff sometimes. Moves things around on me. Actually prefer PowerPoint. But you guys, I don't think have PowerPoint on your Chromebooks, right? Most of you, that's why I'm forced to use Google Slides. Which it's okay. And I don't use the Promethean software or not Promethean, the Smartboard software, because you guys don't have that either. So I'm stuck. I'm stuck with the monopoly that is Google. Anybody still using this slide at all? Okay. Let me double check online and see if anybody else came on. Because I wanted to be able to make sure that if any of you have an issue with the skeletons, that I can address it. I don't want to go super fast, but okay, I don't see anybody else here. And I think I still have only gotten a couple of things into Parent Portal. I haven't graded the digital skeleton equation #1 assignment, nor the lab. I need to go back and double check and make sure that there's not anybody that missed that quiz. I'll do that towards the end. I'll have it. And like I said, these little letters that are after the compound are just a state of matter. Nothing to do with math or multiplying anything. It's just, is it a solid, a liquid, a gas, or is it in the aqueous state? It will only take us probably 10 minutes maximum to get through this part. And like I said, the assignment, I'm pretty sure I linked it right in Canvas. It's a Google slide. And you're starting off by literally doing nothing but counting up atoms. The second part is identifying reaction type, addition, decomposition, single, double replacement, and combustion. Yep. Did you get it, Braden? Yep. All right, we're going to just identify. It's very, very similar to the opener. I have sodium oxide up here. So I have how many different elements? Don't add up the numbers on the bottom. How many different elements are two? Sodium and oxygen. Two elements. More than two atoms, but two elements. I have sodium and I have two of those. The subscript tells you how many of the element before it. Okay, and then I have oxygen. How many oxygens do I have? Four. How many total atoms are in this compound? Six. This is as easy as it can get. But like I said, if you can't identify how many of each element are represented, you're going to have a hard time doing molar mass. I don't know how the other chemistry teachers do stoichiometry here. I know how I do it. I know different ways to teach it. I'm going to see, I haven't gotten that far into their notes to see if they split the mole ratio off from the compound or if they leave the mole ratio on the compound. But I am talking like next 6 weeks mathematics. Yes, I think it's next 6 weeks. All right, next one. Carbon tetrachloride. How many elements is in carbon tetrachloride? Two. Okay, this is chlorine. This is not carbon and iodine. I know the Google slides, the I and the L, capital I and an L looks exactly the same, but if I had two carbons, this would be C2 and then I4. So this is carbon. How many carbons do you have? One. No subscripts means that that element has one. The second element is chlorine. How many do you have there? Four. So how many total elements is in carbon tetrachloride? Five. Y'all, literally, the first half of your assignment is this simple. Now, these are the easiest ones to do. There are no parentheses and there are no coefficients. Not the entire thing. The first half of the assignment is literally counting atoms. The second half is it addition, is it decomposition, single, double replacement, the stuff that we were doing towards the end of last week. And like I said, I'm not really worried about this part. I'm worried that you guys are still struggling trying to get your formulas down for your skeleton equation, which is what we were reviewing yesterday. All right, this one, calcium chloride. Now the difference between this one and the previous two is this compound has a coefficient. But still, how many elements total are in calcium chloride? Two. I have calcium. Now, according to what we did with the opener, with the coefficient as a multiplier, how many calciums are in it the way that it's written? 5 of them. I originally had 1, okay, because there's no subscript, but the 5 multiplies everything that's behind it inside that compound. So the second element's chlorine. How many chlorines do you have? 10, because it's 2 times 5. How many total atoms do you have? 15. This is really sort of doing a major precursor to how many atoms are inside a compound, where you literally would do this kind of stuff. But like I said, when I do stoichiometry, I pull the coefficients off in what's called a mole ratio. And I can teach you 2 different ways to do it. Most of my students prefer the fence post. Some of my students prefer the parenthesis, the factor method. I don't know which way your math teachers teach you. We'll find out when I hit dimensional analysis. Or that's what that big word, stoichiometry, just means chemistry math. How do you cancel out units to get to your answer? This is a big word. Okay, any questions so far? This would be carbon trioxide. I still have 2 elements, carbon and oxygen. Carbon has how many? 2. 2 times 1 is 2. How many does oxygen have? 6, because 2 times 3 is 6. And the total number of atoms in this particular compound is 8. Ooh, I need to hear the pick on. What about when it decides to actually work? What does it say on 70? Right now, I believe the next one is when we start dealing with parentheses. It is. I got one more after this we're going to do. This is the way it's written is not right, but it's okay. This would be yeah, the way it's written isn't right, but that's okay. It's no big deal. We've got cobalt and we've got phosphate. Phosphate has, just inside the parentheses, has one phosphorus and has 4 oxygens. One phosphate, one inside parentheses has 1 phosphorus and 4 oxygens. I haven't multiplied anything out. I'm just saying the actual phosphate ion is 1 phosphorus and 4 oxygens that are stuck together. Now I have a total of 1, 2, 3 different elements. Cobalt, phosphorus, and oxygen. 3 of them. How many cobalts do you have?
12.
How many?
12.
12. 4 times 3. Phosphorus is going to be next. How many do you have there? 12 also. 3 times 1 is 3 times 4 is 12. 3 times 1 is 3 times 4 is 12. Okay? And then how many oxygens do you have? 48. 3 times 4 is 12 times 4 is 48. And when I add them together, I have a total of 72 atoms in here. Now I'm looking at this, I can see that this actually, that shouldn't be a 3, but I'm not going to try to confuse you. We're just going to take it the way it's written. Miss Castleberry put this together and I pulled it off of her slide without even like second guessing it. And I know in my chemistry brain that this can't be a 3. I know phosphate's -3. But if the cobalt is +3, then they would have canceled out to 0. So honestly, what this should have been was a 2. But I am not going to split hairs right now and try to confuse you. This is more multiplying to figure out how many of each element you have. I didn't even proofread the Google slide that she made for the assignment. I need to go back and do it. Calcium hydroxide, which is the one that I had on the board and I erased. I have calcium, oxygen, and hydrogen. I have 3 elements here. Calcium is the first thing I see. How many do you have? 3. This 2 only affects the hydroxide. Calcium doesn't have a subscript. You can't see me pointing on one. The calcium doesn't have a subscript, so it's 3 times 1. The oxygen, however, is 2 times 1 times 3, which is how much? 6. And the hydrogen is also 2 times 1 times 3, which is 6. So that's 2, 2. Both of these are 1 inside. So 2 times 1 times 3. So that's what, 12, 15? Oh, wait. Let's just say 15, not 19. That's a typo. Fix it. No. This is the typo. Y'all should be used to the fact I do typos all the time. Sometimes you may actually learn from my mistakes, especially if I talk through them as I'm fixing them. Now, I did not do that intentionally with the thing that I recorded for tomorrow, because I didn't want... I will in-depth explain how to do combustions and a polyatomic that is on one side and not the other specifically on Friday, because I had Friday set aside as a work take anyways. Because I know some of you, it's going to be this quick with balancing, and you're not going to work them out longhand. You're going to be like me, and you're literally going to ping pong back and forth using your fingers. Some of you will not be able to do that. I personally still have to work combustions out longhand underneath them, especially the ones that have coefficients that are in the 20s, 30s, and 40s. The ones that have coefficients that are in the single digits aren't necessarily that bad, but they're not all that simple. All right, I don't think there was another one. No. Okay, so in Canvas, let me make sure. Your assignments in Canvas. Okay, so right here, because it's a Google slide thing, you're going to make a copy of it. I know they can't see what I'm doing on here. Let me change the way I'm presenting. Stop. 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 Let me change it so they can see it. Okay, so if I go, so you're gonna, and I know that it's not your mode, but you're gonna go into Canvas. Gosh, our computers are so slow today. And you're gonna hit the counting atom slides and you're going to make a copy. Okay, and then I know that I have to show this to you in presentation mode, which means if I can't, like, if I click, it goes forward. This is exactly what we just did. Now they just gave you an example over here on the side. So the iron originally had 2, but it was 2 times 2, which was 4. Okay, the 2 affects the sulfur and the oxygen also. This 3 affects the sulfur and the oxygen, but not the iron. So for the sulfur, which was originally 1, 3 times 1 is 3 times 2 is 6, which is how you would get that one. And then the oxygen, 3 times 3 is 9, times 2 is 18, which is how you would get this one. It's just giving you an example up on the side. So you're going to do that for the diphosphorus pentoxide. You're going to do that for the carbon dioxide. Remember, the coefficient multiplies everything. The subscript only affects the things inside parentheses. It doesn't affect things that are outside parentheses. You're going to do it for the hexacarbon. That would be DOCA. Well, we don't go that far into 12. That is a fuel. That's not butane. I know it has a name. All the hydrocarbons have a name, but you're going to do it for this hydrocarbon. I don't have them all memorized. You're going to do that for, this is sugar. This is glucose. The magnesium phosphate. I'm not seeing any typos right now. This is the first time I've actually proofread this page. For the ammonium sulfide, remember this 2 affects this guy, both of them. Doesn't affect the sulfur, but the 4 affects everything. And then you're going to be identifying on this part, what are the reactants, what are the products, and what does this arrow mean? You're going to identify the state of matter. We just did this in the notes. And then you're going to be identifying reaction types for the last part of it. And that's all of the last of it. And honestly, you guys should all be able to finish this no problem in class. Let me go back to here. I will wait. Am I here tomorrow? Tomorrow's Wednesday. Yes, I will be here tomorrow. I'll be able to do everything with you guys tomorrow. Let me stop the way. Hold on. Come on, change to the tab. Chemical reaction, share, present. Okay, now I'm going to turn the light on. I'm going to double check real quick assignments that I have. I know some of your questions. Let me go over who's missing. I know, that's what I was expecting, was the skeleton ones. But I want to go over who is missing. If you didn't take the quiz yesterday, but I have to go into the grade book for that. I'm not sure if I recorded it either. No, I did not record it. So, okay, so the quiz from yesterday, if I can find it. There it is. That person's not here, not here. Luke, you did not do your quiz from yesterday. You're supposed to. Sebastian's not here. That one's not here. Robert. Jeremiah. I think, Jeremiah, you were absent yesterday. I think. There is a quiz that is in Canvas from yesterday that is identifying reaction types. It should take you a whole whopping 3 minutes to do. Now, the skeleton equation one from last week, okay, I have some digital submissions that I have not graded. I got a paper one from Tiffany, from Mia, and from Jimmy. Yeah, I got a digital submission from Declan. This was from the 7th. From Declan, from Sebastian, from Logan, from Reagan, from Alexis, and from Kyle. Okay, if I did not just mention your name, Then the one from the 7th, I have not gotten, and I'm about to not like take it after today. That was skeleton equation 1, number 1. The one from yesterday was number 2. Now, if you turned in your lab, y'all, I just have not had a chance to get to it yet. If you turned it in yesterday, I didn't grade it yet. Let me look in here. This is as of, okay, I got skeleton 2 from Jimmy. I got the types from Luke. I have your skeleton 1 here, Braden. I've not graded it yet. It's still stuck in here. And then I did get a paper submission of the lab from Valerie, Jimmy, Braden, and Mia. I got a digital submission of the lab from Declan, Caitlin, Alexis, and Kyle. I have not graded this yet, though. What now? Products are on the right. They are produced. We read left to right. So we start on the left and we end on the right. Okay. So, yeah, it may take me a while to get it in because I'm sort of backed up, unfortunately. Okay, so who had a question as far as the skeleton equation stuff? Okay. So with prefixes, you go to charges. There's a prefix, the prefix tells you how many. If there's no prefix on the first one, you have 1. So there's just 1 thing, but it's how many CLs. Yeah, it's PCL. When you have prefixes, monodi, tri, tetra, you do not need to look up the charges. It's when there's no prefix at all. Like sodium chloride, magnesium chlorate. There's no charge or no prefixes at all. That's when you have to look up the plus and the minus and switch them. Now, if it says that it's like gaseous oxygen, or maybe it says it's hydrogen gas, or combines with bromine, and it's not iod, those are the ones we have to make sure that if you need the 2 or not. 5. Tetra's 4. Is there another question either with the skeleton? That has to do with state. So if S is solid, that's an L. That's an L. I know it looks like. Normally, when we do that in parentheses, we use a cursive L, like if we're writing it out. But unfortunately, this is all digital. Aqueous. AQU. EOUS. I had to think there for a second. I'm going to stop this. And if any of you that are online